Good day, doctor. My group mates and I did experiment 7, which is psychometric process heating and cooling system. Our lab was during session 2 and we are from group 4. My name is Pavanisha and my group members are Chong Wan Singh and Ahmad Saidi Shuib. Alright, the theoretical is an air conditioning system can carry out a few functions such as heating, cooling, dehumidifying and humidifying. Heating is the transfer of energy to a space or to the air in a space by virtue of a difference in temperature between the source and the space or air. Heating can take place by heating the air and turning on the blower at the same time. Cooling is the transfer of energy from the space or air supplied to the space by virtue of a difference in temperature between the source and the space or air. It usually is done by switching on the compressor and then reducing the temperature in the air conditioning system. Dehumidifying is the transfer of water vapor from the atmospheric air. Latent heat transfer is associated with this process. This process is most often accompanied by circulating the air over a surface maintained at a sufficiently low temperature to cause the condensation of water vapor from the mixture. It is usually done by turning on the humidifier in the air conditioning system. Last but not least, humidifying is the transfer of water vapor to the atmospheric air. This process is usually accomplished by introducing water vapor or by spraying fine droplets of water that evaporate into the circulating air stream. Now let's look at the objective of our experiment. Alright, the first one is to measure air psychrometric condition before and after the heating process. The next one is to determine heat and mass balance across the heating process, to determine the specific heat capacity across the heating process, to measure air psychrometric condition before and after cooling process, to determine heat and mass balance across cooling process, to determine the specific heat capacity across the cooling process, to measure air psychrometric condition before and after the humidification process, to determine heat and mass balance across the humidification process, to construct the refrigeration cycle diagram for the air cooling system and the energy balance between the air refrigeration circuit and the change in the air enthalpy and its mass flow across the evaporator. To measure the air psychrometric condition before and after humidification, heating, reheating, dehumidification and cooling process. Thank you.
Detailed operating procedure of the heated air conditioning system unit. So I am Chong Singh. So there are 6 experiments here. So first one is start of the experiment, and second, third, fourth is the heating, cooling and humidification. These 3 experiments is about compare the initial and after the heating, cooling, humidification, what happened to the data and what happened to the air. So the fifth and the sixth experiment is the comparison experiment. We compare cooling and humidification and cooling and dehumidification process. All these 6 experiments are non-circulating air system, mean that we will not circulate the air, we will always use the fresh air. So now we start out the experiment. We make sure the heated air conditioning system is steady, computer software are running, make sure temperature and relative humidity are back to normal before start the other experiment. So this is the picture of the heated air conditioning system. We got the software and computer, blower, heater 1 and heater 2. The green color small one is actually is the equipment to measure temperature and relative humidity. And we also got air conditioning compressor, air ventilator, and humidifier. When the air ventilator will let the air blow into it, and the blower will draw the air into the heater to make the heater hot, and make the heater hot the air. And the compressor will make the air become cold, and it will pass through the air ventilator after that. So this is one of the example of the system diagram. We got this is for experiment 5. We got the blower, humidifier, and the compressor. Why we know it is switched off or switched on? We can see by the color. If the color is green color, mean that we already turn on. If it didn't, then it is off. So next, we move to the heating experiment. So every time we do the same thing, which is we let the blower switch on for 5 minutes first, and we set the air flow rate. So this time we set the temperature as 50 degrees Celsius and we turn off the heater 1. So heater 1 is enough, that's why we didn't use the heater 2. So we make it run for 10 minutes. And it will stop heating after it reaches the desired temperature. It will maintain the temperature as 50 degrees Celsius. So how they heat the thing? Actually is because the electrical current heat out the heating coil in the unit. So the electrical current is turned into heat. So when the blower draw hot cold air into the heater, if the air will pass through the heating element and push out into the room. And we record all the data after the 5 minutes and 15 minutes. And we observe that the exhaust air was warm. So after that, we do the cooling process. We also do the same thing, let the blower switch on for 5 minutes and record the data. Then this time we turn on the air conditioning compressor for 10 minutes. We only record the time when it is -5 degrees Celsius so that the all process and data will be more accurate. And that's why they can cool the air is because we got refrigerate inside the coil. It can change the gas to low temperature. So when the blower moves warm interior air over this cold refrigerant fuel coil, it can make the air cooler. So we record the data again and we observe that the air was cooler. So it is some of the simple working principle, like why? Because when hot air flow over the cold low pressure coil, the refrigerant will absorb heat and change to gas from liquid. So the air conditioning need to back to liquid again. Why? In order to keep the cooling efficiently, we will repeat to use the thing again and again. So the compressor put the gas under high pressure so it can make it become compressed liquid. Then when the gas cold, it will change to liquid. So the conclusion is the liquid refrigerant will change to gas by the heat absorption and the compression will make it back to the liquid again. The fourth experiment is the humidification. So first one, we also do the same thing, let the blower switch off and we set the flow rate. But this time we switch on the humidifier and a large amount of water vapor will release into the PVC duct. Then now we turn on the blower for 10 minutes and we can see that the air disperses the air vapor very quickly. So we record the data. So this kind of humidifier is evaporative humidifier, which has a reservoir, hold cold water and dispense it into a basin. A filter absorbs the water from the basin, so when the fan inside the humidifier will blow the air through the filter. That's why it will evaporate some of the water air when the air passes through water. So the exhaust air was a bit colder, but it's not that cold by the air conditioning compressor. So the experiment 5 is a comparison experiment. So we turn on the blower for 5 minutes and we record data, then we switch off. When everything becomes equal, then we turn on the air conditioning compressor and the humidifier together for 10 minutes. And we record the time degree when it is -5 degrees Celsius, just like before. And this experience is different with experiment 6 with the presence of the humidifier because we want to do a comparison. So this time we also do the same thing as previous, but this time we only switch on the air conditioning compressor without the humidifier. So after we do all this, we compare the value between the experiment 5 and experiment 6, and we will explain what happened in our next slide for the discussion. Thank
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syahid Shuaib bin Ahmed Atfi. My metric number is 197844. I would like to talk about our discussion for experiment 7, which is air conditioner. Air conditioner, the process associated with the removal of heat from the air is condensation process that occur in the evaporator. When the refrigerant enters the evaporator, it is in the low pressure and low saturated temperature. Since the temperature of the evaporator is much greater, this causes the refrigerant to undergo evaporation by absorb heat from the surrounding. As the result, the temperature of air would be much cooler when it leaves the evaporator. For the experiment 7 air conditioner, we need to determine the air psychometric conditioner before and after humidification, heating, reheating, dehumidification, and cooling process. This experiment shows the importance of the psychometric chart to find the scientific volume, scientific humidity, and others. For the experiment we have done, we know more about the air conditioning system. Usually, split unit system will be used to almost building. In split unit system, the compressor will be installed in the outside of the building that are usually used to heat and cool one or more rooms. The experiment 2 is heating process. After we open the blower, we need to wait 5 minutes before we record the data for HT2, RH2, HT3 and RH3. After that, we set the preheater set point at 4 degrees Celsius, which is below 50 degrees Celsius, and we wait for 10 minutes and record again the data. We see that the increase of the temperature in HT2 and HT3. After finish record our data, and we can get the preheater power, which is 1041 watt. For this experiment 3 is cooling process. We need to measure the air psychometric condition before and after cooling process. So we can see that air flow rate is 61 meter per second. E1 evaporation in is negative 9.6 degrees Celsius. E2 evaporation out 32.4 degrees Celsius. We record E1 and E2 after 15 minutes. Before we start an experiment, we need to wait the E1 until negative 5 degrees Celsius, and we start first 5 minutes to record. So the temperature of air would be cooler when leave the evaporator. For experiment 4 is humidification process. Humidification process, we just need to add the moisture and we record all data in HT1, HT2, HT3 and HT4. For experiment 5 is cooling and dehumidification. We need to cooling and we open the humidification. And we record all data for first 5 minutes and after 15 minutes. For the conclusion, this experiment had 5 processes, which are heating, cooling, humidification, heating and humidification, and cooling and dehumidification. The cooling process will cause a reduction in the temperature. For the heating process, cause the increase in temperature. These two processes do not have moisture, so humidity content are not considered. For the humidification process, we add the moisture. Other than that, for cooling and dehumidification, has a reduction in temperature as well as a removal of water. So the moisture content will decrease. Lastly, the heating and the humidification process cause the temperature to increase in the moisture content. This energy load of the process is the highest because it needs energy to raise the temperature and heat the water to add into the air. I think they are for our group. Thank you.